started here in just a second, so pile in or pile out as you need. Okay, let's get started here. We're trying to beat some wonderful Nebraska weather here. It's going to be kind of a condensed review, but we'll do our best to cover as much as we can here. Can you all hear me back there? Okay, I couldn't hear you. Okay. All right, what we're going to do is a couple things. I'm going to hand out some awards here as part of this, too, to save some time. But I want to just first off, as part of design, just thank you competitors for coming out and doing such a terrific job. And all the volunteers we have, not just judges, but the support staff. Thank you so very much, Kaylee and everybody. What I'm going to do here is start off with some awards right away for the 3-view drawings. You may have seen those 10 drawings that were posted up on the wall in the design tent. And we take the 3D drawings pretty seriously. And the reason is we don't get to really see your car before the design competition starts. We'd love to have you delivered first. We can test it out for a few laps, but you don't do that. So we have to use the 3-view drawings to get appreciation for the scaling, what's going on, and give them more visual than what your design reports show. So we do take it seriously, even in this day of CAD and all the other CAE tools. If you don't know how to draw a clear drawing, you're just going to make junk in CAD as well, okay? So make sure that you've got a good understanding of how to do a proper drawing. Just because it can be auto-generated doesn't mean the lines are crisp or that it's been properly dimensioned or the dimensions are sized right or the auxiliary information is there. Yes, it came from a machinist point of view. How do you build a device and get the proper 3 views or perspective drawings? But it's still very helpful. You'd be surprised at how many machine shops still need that. Just an STL file is not enough. So here are the names of the teams. And I'd like you to do is we have here some awards for you in the way of books. Some of the Carol Smith books. Teams 4th through 8th place are all going to get a Carol Smith book here. So I'm going to read these off right now. Let me ask Kaylee if she's going to pass them out or not. You're going to pass them out now? Okay. Okay, 10th place was University of Oklahoma, car 59. Come on up and get your 3-view drawing. Is Oklahoma here? Great, I get to keep it. Okay, 9th place, EV car 217, University of Pennsylvania, 9th place. Come on up. Way to go. Thank you. Way to go. Good job. And make sure you read that Engineer to Win book. It'll make you dizzy. Okay. 8th place is a team that's been known to do pretty well here in Lincoln the last couple of years. Car number 1, Texas A&M University. We have one of the Aggies here. Texas A&M here. Okay, my wall's going to be pretty full. Okay, 7th place, University of California, San Diego, car number 8. Look at this, they're running up here for the award. This is great. Good job. Okay, 6th place is another EV car, car number 229, Western University. Anybody here from Western? Okay, so now we're up to 5th place is car 73, University of Pittsburgh at Pittsburgh. Okay, fourth place is Rutgers University, car number 6. I know some of you are here. Yep. Okay, so now we're into the top 3. Top 3, you get a little more gifts here. You're going to get 3 of Carol Smith's books. Prepare to Win is a set. Is that right? 3? 5. Okay. I guess I should read the other 2, huh? Car number 36, University of Southern California, is 3rd place. Okay, 2nd place is car 96, Wayne State University. Are you here? Everyone else is running. A little precedent. All right. Thank you. Congratulations. Okay, and the team that has had the best 3-view drawing in the estimation of our chief design judge is University of New Mexico, car 42. I believe they're gone. Their trailer was gone earlier this afternoon. So, okay. So what we're going to do here, we've done a little bit of this the last couple of years. I think it's probably a little more enjoyable, entertaining, and probably more informative than me just up here blabbing up around. By the way, you may be wondering where Steve Fox is. He's usually up here helping me out with this. He had a family obligation he had to take care of this evening, so he had to leave earlier today. So I'll do my best. What we're going to do is I've got 3 cars up here that I'd like you to have a look at. We're going to have some students come up and talk about these cars. I'll give you a little bit of some feedback of some characteristics, but I don't think anyone can tell you as much or as well about them as people have been working on them for the last year. So what I'd like to do is let's pick a car here. Let's take a look at the car right here in the middle, Ecole Polytechnique, Montreal, car number 3. You should have Renault and Matthew, okay? They did not do 90% of the work, right? Real quick, 415-pound cars, 50-50 weight distribution. You'll notice, like the other 3 here, they happen to be running 10-inch wheels. It's not an endorsement that you have to, but there's an engineering reason for it, which I think they're going to tell you about. Rotax 450 single they're running. It is a tube frame car, not a composite car. Their target, as they were telling us prior to this event, they didn't tell us prior, they told us here, was that a well-balanced car, okay? Not just the balance with regard to how it is from the driver's point of view, but balanced in terms of the engineering. They don't want to be a great powertrain and a so-so suspension. They want to get all the elements fine. It's almost like, hey, make most of the car at 95% rather than trying to make one off the moon and sacrifice the other. That being said, we did a little work on suspension and cockpit controls per the judges, which we probably won't address too much here. But they try to get the car done pretty early and keep it very straightforward and get a lot of testing done. When did you actually start testing the car?
When you started testing?
Yes.
We started testing that car late March. Our objective was to release the car mid-March, and we're quite able to do that. The weather in Canada was just not fair enough for us to to go on the track that early. But yeah, we started rolling the car late March, and up to today we have more than 550 kilometers done on that car. So we were at 250 for Michigan.
So they put another 250 kilometers on it, my math is right? Close, right?
Yeah, right.
So that's a good amount to get done in the last 5 weeks. So the other thing they looked at is the tire selection. The comment you made earlier was you looked at the big picture with regard to tire selection. Tell the crowd what that means.
Well, so basically what we were really looking forward to was this whole summer we were waiting for the new data from the TTC testing. I can't highlight how invaluable that information is. So if there are any teams out here that don't have access to the TTC database, it's really worthwhile spending that $500 to get the lifetime subscription to that data. So basically, right off the bat, as soon as we had the data, we started fitting it with the models that one of our team members developed over the last couple of years. And we were so happy with the results of these new smaller 16-inch wheels that we purchased a brand new set of those and a brand new set of the tires we were running last year to run them back-to-back in early testing sessions with last year's car. And that basically confirmed in our minds that that was the tire we were going to run. And then we went from there to change a couple different things on the suspension to match better the new tire characteristics and everything.
Okay. Also, it's an aero car, clearly. But you took a different approach. You didn't really treat it as an aero car up front, did you?
No, exactly. Our main idea was basically over the last 4 years to get the car as perfect as we could without aero, and then start adding aero to it. Start simple and then get it more complicated. Be sure that we all understood what the car was doing before we started adding this new complexity that was aero to the car. And we also wanted to be sure, obviously this being our first year really running aero, that we had a fallback plan at all times that we'd be ready. So we were not only testing with and without aero to compare the two, we were also making sure to have setups for every single event without aero.
So yeah, it's a good lesson, by the way, because unless you're at a Formula One level where they got super smooth, we call them billiard board tracks, in real racing conditions, or obviously in a street vehicle, you got a lot of different types of terrain that you've got to run through. And I don't mean the driver going off course. I mean the actual road surfaces change a lot. They could have laid the course out here a variety of ways, and you may have actually caught in bigger bumps than you've got. So, and then the whole rain factor there too. So to say, why build an aero car because that's what everyone says to do, is not really the right reason for it. Anyone who's good at kinematics will know that you have to keep that tire on the ground, and I don't care how much downforce you have. If the tire is not touching the ground, what's your coefficient of friction at that point? Pretty much zero. So you've got to keep the normal force on that tire, and it's not just about just throwing more wings at it. So getting the mechanical grip down first is a very good choice. Naturally, you had to make some adjustments. You had to stiffen things up and so forth once you did go to the wings, but at least you had a fundamental base that was working well. Okay, I want to shift a little bit about some of the team management stuff. You start off with 15 members. I'm sorry. You have 15 members. And that's not a lower number than they started with. It's actually a higher number than they started with. Is that right?
Yeah, that's correct. Well, when we start the year at the first semester in autumn, we are like a very small team. We have to recruit quite a lot because every year we have some members that graduate, and like I guess that's pretty much the same thing for everyone here. But we try to always every year recruit a few members. Even though we're a very small team, everyone in the team is very, very involved in it, and everyone knows quite a lot about the car. So that's, I believe, one of our main strengths.
Okay, so keep that in mind. I've touched a lot of you teams. You start out with a huge number of students, and you end up with a core group. They had a core group that grew. So hats off to you to keep people attracted to do this event. It's very difficult to do this and keep up the effort. Particularly consider the next thing. Would you care to guess how far away their shop was from the school? Go ahead.
Well, in kilometers, I don't really know, but it's like a 20-minute drive, 1 hour in public transport. So that's a bit of a turn-off when you try to recruit some new members. So, like, we know the guys who go to the shop and stay with us. They're pretty strong. They're made for it.
They don't have a lot of bunk beds at the shop either, maybe a cot or two, right? So that's 20 minutes each way. So 40-plus minutes of the day is taken just on the road. So that's some commitment. You guys have to do something else at the top of the hill campus and expand it, get over there. Maybe Elon can build a boring hole to get it more quickly there in the future. You also had on your team a very thorough parts numbering system that the judges really, really enjoyed. What was the genesis of that? I mean, and how have you used it?
I don't know if you want to.
Well, basically one of the things that we did to have our part numbering system really like on point was to follow kind of what's laid out generally in the cost event. So the cost event was a pretty good basis for our whole part numbering scheme. So it's basically we have two letters that identify the section and then a numbering system that's well set out for all the sub-assemblies. So it's very easy for us to identify which part goes on which sub-assembly. And oftentimes, a lot of the team members even know like part numbers by heart because you're working with the part so often. You're opening it up in CAD, you're opening up the assembly, playing around with stuff like that. So then when it comes time to build the car, it's always very easy to, and we pay a lot of attention to always writing down the part number on machine parts that we put in the envelopes and then send over to the shop, because maybe it's not the same person that made the part that's going to assemble it on the car. So we want to be sure that the right part's getting put in the right place.
I've heard a lot of cases where teams say, well, we only have a few people. We don't bother with all that stuff. That's for the big teams that need all the administration. As you go on through the years with your team, you'll be gone making big bucks. But the other members of the team will really appreciate that kind of work you guys do, and it makes the team better and better into the future. That legacy data, though you might not use it in exactly its existing form to make the car the same way, you learn what worked, what didn't work, what aspects would work, what the problems with suppliers, these materials, getting the materials, whatever it might be. You are actually hitting the road running that way. So no matter how big your team is, it's worthwhile figuring out a way of doing that. Always the problem is doing it efficiently. You don't sit there and waste all your time doing it. It takes a lot of time. So you've got to have various methods, and that's a number of things you can figure out how to do that. There's a lot of good database programs out there. You don't have to design the whole thing from scratch. Your team was recognized for having very good data use. Actually, you don't have the most sophisticated data system in the world. You've got one of the AIM Evo systems and the performance electronics, okay? But you got a ton of data. The judges were quite impressed at how much data you could actually accumulate there. So it was a good selection of sensors. There again, you don't have to spend big bucks to do this stuff, and that kind of system goes from year to year, may go to the next chassis. You did some nice analysis, some wave analysis, some one-dimensional analysis on the engine development. Let's see. There was, including a combustion model too. You didn't just do the wave fronts, inlet and exhaust, but some combustion work as well. In the car, one knock is the judges weren't too crazy about the headrest arrangement there. Some drivers, the way they fit, their head was kind of a odd angle with their neck, and some visibility issues there. I don't know if it's because the shock's sticking up or what might be, but different drivers are different types. Obviously, we got the 5th to the 95th percentile constraint, and you want to be able to honor that. So just always keep that in mind. Tire modeling, we talked about your understanding. It was quite good. I'm sure you learned a lot, not just looking at the TTC, but understanding what the heck the TTC meant when you saw some of those terms. It's a pretty thorough task to get into. Tell me about, one of our manufacturing judges mentioned something about scanning some items with an electron microscope. Is this the physics department? What we got here?
Yeah, well, actually, that was a sponsor offering that we got from a company called Innovametric that worked with us, supplying licenses to do that 3D scan on the chassis. This year we used for manufacturing, because one of our goals was to roll out much earlier. We used a different method than the previous years to build the chassis, and we wanted to validate how wrong would it be. In terms of where the suspension points will be placed. So we work with that company to actually scan the suspension points and fit them onto the CAD model of the chassis to see what type of error was there. And afterwards, with our full vehicle simulation, we were able to kind of see if that variation of the points placement, what kind of lap time issue would that cause to us, and kind of quantify if that error was acceptable and if that method of jigging the frame would be great for the next years.
So anyway, you can see they're a well-balanced team. They've done a lot with a pretty tight budget of time in terms of the number of people available. In terms of the financial budget, it was constrained as well. And time in terms of having to go back and forth to the shop and so forth. So you can do quite a bit. You don't need to waste a lot to do that. We're going to move on to some other teams. I just mentioned their wiring was very well done. The documentation, it's all very, very, makes it a lot easier to be able to service the vehicle. So very, very good job with that. Thank you very much. And we're going to bring another team on here. But I say great job as one of our finalists here.
Thanks to you.
See you in a bit. Okay, so we've got another internal combustion car here. It's a car you may have never seen before, because I don't know if this school has ever really participated in this event before. They've got an advisor who claims that he knows something about this competition. I'm not sure how that came about, but Bob Woods has been around for a long time doing this, involved in sports car racing, a lot of different areas that he's into, and it's one of the reasons that this competition is what it is today, is the amount of work that he's done over the past. So his current crop of students have come up with a very fine specimen here. Car number 5. If you want to come up, Scott and Tim, if you're here. Okay, so the car came in at 471 pounds, not the lightest car in the world, okay? We as judge often like to say, oh, yeah, F equals MA, we've got to get the acceleration. But if you do the rest of the items right, and you get the traction down, or up, as the case may be, you can sometimes afford to carry some of that weight around. You don't want to have to, but you may need to for other areas of the vehicle. By many people's cases, it's a little more than we'd like to see, but you got a very complete package. It's ergonomically pretty nice, so it makes a big difference there too. A driver who's more comfortable behind the wheel, guess what? It's often going to go a lot quicker because it isn't to focus on the distractions when they're driving. So from an ergo point of view, that always is helpful. They're using the 10-inch wheels like I mentioned. It's also a space frame car. It's not a composite car. Instead of the single cylinder, they're using a Honda 600 4-cylinder. Not a ton of modifications to it, but you had a custom pan on there, I believe, and a dry sump, if I'm not mistaken, you've done on there as well. With motorcycle engines, despite what a lot of engine builders who like a lot of repeat business have told me, you do need something to keep that oil under control, and a dry sump is about the best way. So we've blown many motors without them. Here again, this car is a very well-balanced car in that they've scored very high on all their areas. It was not, knock it out of the park on suspension or aero. They in each area were quite good. Your goal was engineering balance, 95% of the way on all the areas, and then you work on the last 5%. Tell us what challenges you had doing that a little bit here. Scott or Tim?
That's all you.
They're in alphabetical order, Scott and Tim. So.
Well, there were a lot of systems that it's a complex car if you look at it, and so we wanted to do something that was simple, easy to manufacture for us. And so really you look at our aero system, and it's complex and has a lot of things, both design and manufacturing, that went into it. And so coming up with ways to manufacture it faster, pretty much for every system, coming up with ways to manufacture the car faster, meet our deadlines. We wanted 3.5 months of testing, so we really had to reevaluate a lot of our previous designs to help them meet that manufacturing goal. So.
Yeah, you did that. You did test quite a bit. I will say I found it very curious. I first saw your team on Thursday morning. One of the first things I always ask each one of you, probably heard me ask, is how much time you got on this car? Nice conversation starter, Dave, right? And I hear the number, and then it's, okay, what broke? We didn't really break anything. What does that tell you? You got to push it harder, right? Or things are too large, okay? You need to break something if you're testing and find out where that weak point is, and then you can always, restructurally build that up. But if nothing broke, either you had the perfect design, none of us have ever done, or it was over-designed a little bit. So, or you weren't testing hard enough, okay? So just keep that in mind. You were very well prepared for design. You had the right supporting document. Our judges would ask questions. You'd often have the binder with the illustration right there before the judge even finished the question. So clearly you've understood what the objective design is, communicating quickly. That's a lesson when you get to industry. If you can't sell your design and communicate it very, very clearly, it doesn't matter how good it is. It's not likely to be taken or adopted by management. One reason engineers love to get into management right away so they can be the smart ones over there. The team, you got 23 members and 3 associates. Tell us what an associate is.
So to become a member of the team, it's all volunteer. So people will basically show up, and to become a full team member, you first have to become an associate. So that basically acknowledges that you've been showing up and volunteering with our organization. After you have shown that you see the bigger picture and can be a contributing team member, then you get promoted to a full team member. So it's really a good way to get people involved and acknowledge that we see that they're doing work, and try and engage them more into the team.
It gives them a chance to kind of get their feet wet too. Is this something they really want to do? They have to make a certain commitment that you want to be part of your team. Okay. Nothing worse than when people are just don't sure they really want to do it, and then midway through the process they pull out, and that core competency is gone. So you always want to make sure you train the underclassmen the best you can. Sometimes freshmen and sophomores are actually a great source of ideas because they have a certain innocence that you come on, you learn more, you think you know it all, and it turns out the younger people have some better ideas as well. So always bring the youthful in, and the system will keep getting better. You meet a couple times a week, okay? Is that all 23 members, or is it the department heads, or how do you do that with your get-togethers?
So yeah, we have a Wednesday meeting that all the team members are supposed to be there. We have a meeting presentation that's just an update of the progress that we've made, all of the updates for the week, manufacturing, testing. We kind of adopt it to a different purpose throughout the year, because at the beginning of the year, obviously, it's design updates. Certain point through the year, it becomes the manufacturing updates, and then towards the end of the year, it's testing. So it's a really good way so that every team member tries to get something done so they can have something on their slide to show that they have done something, and also inform the entire team of something that they've completed.
The list of features that they've done and tested and gone over and over are countless. I can't list them all here, but the dry sump was one I mentioned. Even checking out how they lube the fasteners and proper torque specs of the fasteners so people don't over-tighten or under-tighten that. The wiring schematics, just like the other top teams have. The car was well balanced, both wet and dry. You tested in the rain and made sure that the car was drivable there and what changes to make before you get here and go, oh no, what do we do? That's where having the benefit of finishing early helps. By the way, I'm going to do a quick detour. Finishing early helps a lot with your design report submission, too. We had quite a few teams that got some penalties for submitting their design report late. So I don't want to go on and on about that, but we're going to be a little less lenient in the future. In the past, we'd say, okay, well, if you're a minute late or 2 minutes late, we'll work with it. Or even an hour late, maybe it's a time zone thing. I get less inclined to do that because I'm getting those over and over and over again. We have it set up, I think, as Greenwich Mean Time to submit. And I don't like to have penalties at all, but let's try to always get those in time. I've often told teams, you can turn your design reports in early, a month early, 2 months early, and submit updates, but not after the deadline. At that point, we won't accept those updates anymore, okay? So just keep that in mind. There's really no excuse to have your design report late, and the spec sheet also. I know in this case it was April 8th or whatever, and you didn't know exactly, but you can build something there up in January or February, and you can revise it. Just don't, well, you got the idea. A lot of good things. One last thing I want to mention is your arrow system you have for the front, okay? You have it as a unsprung mass arrow. One of our design judges, I'm not sure correctly, called it an arrow sway bar, okay? Describe for us real quick what your objective was with that and how it works, and then we'll keep moving on.
Yeah, all right. So the idea was, much like Montreal, we didn't want to compromise our suspension with our arrow. Much to our arrow guys' disliking, the arrow doesn't make the car. So using an unsprung system allowed us more freedom with designing the suspension. We were able to run softer bump frequencies and just really gave us more freedom. What the judge was talking about with a arrow sway bar was that in roll, the inside of the wing dips down. So if the wing were to scrape, it'd scrape on the inside of a corner. And so in a way, you generate more downforce on the inside of the turn, and you resist weight transfer a little bit, so it acts sort of like a sway bar.
You're trying to get the wing height consistent and the rake of the wing consistent, even though things are moving around.
That's correct. So
you're actually lifting, more or less, I understand, you're trying to lift the wing as the car dives so that the actual height remains the same, and the aero sensitivity drops quite a bit. So it's a clever idea. Probably banned in Formula One by now. Okay, so we'd like to move on to the next team. Thank you, Scott and Tim. Thanks so very much. Big round of applause. These guys deserve a lot of good work. Okay, we got another car here. Is it raining out there? If so, you can pull in. You okay? Okay, we got another car here, which actually, believe it or not, is an EV car, which came in lighter than the other two internal combustion cars. And that's with the battery and accumulator in there, too. That was always a question. Is that with a battery or without a battery? That was with. It's also a CRFP monocoque. It's not a tube frame car. In fact, it's a single piece monocoque. You look at it, there's a ton of work done to get that right. The thing about that is you got to get that design all done up front. You're not going to sit there and modify and weld parts on it later. They worked really hard with their other hard points as well to make sure that it was not going to have breakage there. And a hard point with a monocoque, you do not want to have a compression of the honeycomb and have a crunch. I had that happen with some Pro teams years ago, and it's got to go back to the factory at that point and start over. So you worked really hard there to get that right with the hard points, 1/2 inch to 3/4 inch thickness hard points, which were spreading out, so it spread the load quite a bit. Rear-wheel drive, not a 4-wheel drive. It's 2-wheel drive with a single motor, 2 AA batteries. Oh wait, no, it's a different car. 5 kilowatt-hour battery, okay. Alcon battery, prismatic lithium polymer battery, okay. They've worked real hard on it, and I'm going to get 2 of the team members up here to talk about that. Etienne and Ella, are you around here? Thank you for coming up here. Okay. One thing I want to ask you is the rules have changed and you are still using a 300-volt system. Why?
As far as what we were willing to do with our 300-volt system, it's been what we've been most comfortable with in the past in terms of part selection. We did know that we could increase, probably without having too much redesign complexity, up to 400, but as far as the cells we had access to, which are quite high in terms of energy density and power density, 400-volt pack was just not feasible.
Okay. How many EV cars have you done now, this team?
Our team has done 6, I believe. This would be the 6th.
Okay.
Yeah.
Okay. So at this point, you should be able to hat with this a bit and realize when we go to higher voltage, we can go to smaller wiring and weight can come down even further. So one of the issues we've had, we actually changed the rules so it was the 600 instead of 300 volts, just because it was easier to get a lot of the appropriate inverters and the motors to be able to run that higher voltage that the rest of the world has done. But the Reinheit controller, everything you have there is relatively routine, what's done there, which I think you did for reliability, and it was a lot easier to get the setup so you can focus on other parts of the car. You had some custom circuit boards you built. Okay, can you describe a little bit of those if you know about the boards you built there?
I'm
Go ahead.
not the one in charge of those, but we have our vehicle controller and our BMS are running on the same dev board, and we have shields that work for both boards, which is a big change we made this year. It's made our car a lot more reliable because we knew these boards would work. And because we are using the same schematic on both these boards, we actually were only debugging one board at a time, or one board instead of 2, which was a huge advantage this year compared to last.
It's a lot of work to do your own electronics. Helps to have some electronics engineers in the room too. But putting it all together is not easy because we have a lot of mechanical engineers and get the electronics engineers to work together. Challenging is probably the nicest word I can say there. You have 30 members on the team, okay? You have 10 subsystem leads. Why 10? Why so many leads?
This year we made the change to have quite a few more leads than previous years because we really wanted to make sure that work was evenly distributed between everyone in our team so that we didn't have one member who had to like basically live in our shop, pull all-nighters for like a month in order to get our electronic system working. This year we decided to split it up into 3 components such that we could really focus on the design and manufacturing of each part individually, which was wiring, software, and PCBs individually, and put them all together at the end, properly test them to make sure everything worked fine and no one was overworked in the process.
How did you select those team leaders?
We don't really have a selection process on our team. We accept anyone who comes. Our leaders are people who previous years were like last year's leaders chose previously this year's leaders and taught them everything they need to know to bring the car to the standards we have right now. Sometimes we have 2 leads for the same subsystem, but we don't really make hard cuts on who's leading what.
That being said, you're preparing people when they get into what they're getting into. I'm going to give away the store here, okay? I've yet to see this in Formula SE before. This is a member handbook. Describe why you did this or why your team has done this and what it contains.
So we have a member handbook. This kind of goes over everything our team does, everything from how we communicate to how we store our data, how we act as a team, what fun things we do throughout the year, what FSAE is. It is basically a really big FAQ. And we distribute this to all of our new members so that they kind of know what they're getting into. It's very helpful for them to get their feet in the water, see what to expect. It has some tutorials on how to CAD, things like that, so that they can get started. And we also have current members use it very frequently. It has our naming conventions to make sure that everyone's on the same page and everything stays super organized. Yeah, that's mostly.
What you're doing is you're letting people know what it's like, get their feet wet ahead of time. They can read through this and say, is this what I want to do for the next 2 or 3 years of my life? And I can tell you, you look at that and it's like, wow, now I know where to find things, I know where the database is, I know where the local watering hole is, everything's in there. How to be an SAE student for the next 3 years is basically in there. So it's actually a pretty quick start to say how much fun this can really be. So that's very good. I'm really impressed with that. It's more than just a social guide. It's all the details, you know, how to turn on the CAD program, how to get in, what our standards are, here's how we do the drawings, all this kind of stuff. And it's always ongoing, so you can adjust it as you need to as the years go on. Here again, you use the tire test data quite a bit, okay? I don't know if you want to comment on that, but the kinematics fundamentals were pretty much sound. Our vehicle dynamics judges were very happy with that. Any other comments on the tire influence on your design?
So we use the tire data from TTC, and as far as our organization goes, we have 2 vehicle dynamics leads and our controls lead, which then work together to essentially build our system up from analyzing that tire data to then the appropriate kinematics for our car and to, in the end, meet the goals we want. Obviously, like, we've looked at the new tire data for the smaller tires this year, but we weren't ready to make that change and instead decided to postpone such a change for a possible next year with in-hub motors.
Okay. Like I say, everything you've got, you guys just hit all the, knocked all the, dot all the I's and crossed the T's. You did very well with all of that. You know, from the regen modeling you did with regard to the, the regeneration, for the braking, the slip-based traction control routines you built up, a couple different modes you had for drive modes. Tell us what the drive modes were, if you will. It's not top secret, is that?
No. So we have a couple different drive modes. An example would be the Excel runs we did. So our first driver went out with pure driver torque control, so no traction control, no regen, which ended up being a little bit much, and with the water spun out and took out the finish line. But then with the subsequent driver, we turned on traction control. We've been testing it for about 2 weeks. So we had started to get confidence with it, and he went a little conservative on the first one, but basically our traction control works with the combination of the hundreds of signals that we have on our car, and the end result was that he was able to get a 3.6 second time, and all he really had to do was press the throttle and let the car do the rest. Yeah.
So it was all well done, very well done. And I don't know if Kaylee's ready for that, but McGill, that is why you're our EV champion this year. Okay, congratulations for design.
We'll step back down, I guess.
No, stay on up here, stay on up here. 3 or 4? 3? Okay, perfect. Okay, so EV class McGill, first place, engineering. Congratulations. Okay, thank you. You want them all up here? Keep them up here? Okay. All right, which one do we have here now? Second or third? We can do. That's fine. Okay. Our second place in EV is car number 204, Wisconsin-Madison. Badgers here. Wisconsin here. I just saw you guys about an hour and a half ago. Okay. Okay, and our third place EV team. Oh, now you got to get the third place trophy. Oh, Kaylee's being nice. Okay. Our third place for EV goes to car number 201, Carnegie Mellon University. Anyone from here? We go. I wish I could put all three of you up here, just not enough time to do them all. You all did so great up there this year. It was phenomenal. We're getting to the point where we used to say that EV cars are kind of like batteries on wheels. You guys are really starting to contest with some of the very best internal combustion cars. So hats off to EV designers. You're doing a very good job. And just keep it up. Okay. Do you want me to lift? Just the top three? Okay. All right, we're going to switch over here to the internal combustion class. It's a different competition, isn't it? Not just a class. Our third place team is no stranger to SAE. They utterly dominated this competition last year and had some issues. There's some issues this year too, but their engineering, I give them a lot of credit. They did very, very good job. Car number 7, Auburn University. Anybody from Auburn here? Got a War Eagle here? Congratulations. Good job. Okay, second place. This team, you actually just saw them, is University of Texas at Arlington. Car number 5. Way to go, Scott. Good job. Okay, and then our top team for internal combustion, this is a heavy trophy, what's in here? Okay. Is Ecole Polytechnique Montreal, car number 3. Okay, so I'm going to wrap up here. I just want to let you know, it's so easy to find in the paddock with the Canadian flag all the time, so we got to get some patriotism, get our flags going. Honestly, I think in our finalist teams, it was a little hard-pressed to pick most of those teams in terms of the top. In some of our scoring, we were literally down to the last decimal place, and one judge or two, some of the judges here would agree, actually would have changed the score. So we actually came darn close to actually having ties going on. So I think the thing you got to remember is in design is different than what happens on the racetrack. On any given day, you could be quicker or slower. Just remember, what you're trying to do with design is be a better engineer for your whole life, not just what you're doing for this competition. It's not just about building a race car. It's about building subsystems and working together with your teammates. And since I got started with this 15 years ago, whatever it is, it's been so enjoyable to watch you do more and more of that team integration. And I'd like to see that continue. It's just great. I watch the camaraderie. Steve Fox and I used to go off to design reviews for teams. I won't say who they were, but they were arguing. You thought they were going to have a fighting match with each other, fisticuffs. I get the sense that, yeah, there's going to be arguments, but you guys are all really enjoy working with each other in each of your teams. So I hope you're finding it a great, valuable experience. And congratulations, job well done.
Thanks, Dave. All right, just so that we can kind of keep the awards there moving quickly, I'm going to ask the guys that brought the cars in if you can move them out. It helps with getting the awardees up to the stages quicker. Also, McGill, I need to get your guys'